We're doing 11.6 part 2. We're just going to finish up what we started last time. We're still going to be talking about solving equations that have rational expressions in them. So let's begin. So guys, the first step on these is to factor the denominator. Right? So I'm going to let you guys do that. This piece here can be split up. This one does not, so I'll leave it alone. And this one over here is the same as the other one, so they'll be the same when you factor them. What method would you use to factor these denominators, guys? Use the box method. So go ahead and do the box method real quick. Remember, there are other factoring strategies, GCF, there's difference of squares, but in this case, it's the box. So I'll give you a second to practice factoring that with the box, and then I'll take your answer from you. So if we do the box method, we get x minus 1, x minus 1. All right, let's continue on. So that's the first step, is to factor the denominator if needed. Yeah, I'm going to scroll it back up in a second. All right. At this point, let's rewrite the problem. But we're going to make some changes on it. But let's start by rewriting it. All right, what do I want to multiply by to cancel out the bottoms here? Well, I want to multiply by x minus 1, right? But some of them have 2 of those, right? So I need to multiply by x minus 1 twice. So I'm going to put 2 x minus 1s on the top of each fraction. Because our goal is that now we want to multiply to cancel, right? Multiply to cancel. So we're going to put x minus 1, x minus 1. And there. So, Vidal, what'll be left here?
Combine my terms?
No. So what would be left here? We're going to cancel.
For the first one?
Mm-hmm.
1.
Just 1, right? Because those 4 things cancel each other out. Stephen, what would be left here? Maybe a little more than that. So this guy cancels this guy out, but we still have another x. Yeah, so another x minus 1 also, right? Oh, I forgot to put 2 x minus 1. I only wrote 1 x minus 1, but I was supposed to put 2, so make sure you guys fix that. Yeah. Yeah. Jedrick, what about the last one? Okay. So these go away, right? And all I'm left is 1. So factor, and after that, multiply to cancel stuff out. let's do the next step here. And at this point, we just have some algebra to contend with. So, Damien, if I wanted to solve this, what would you do first to solve? Want to take a guess? Yeah, I would distribute first. Usually, if you have an opportunity to do distribution, I would do that first. All right. Haley, any suggestions for next step? Okay. What do you think, Cal? So these basically combining like terms, right? We can put those together, and we have our answer there. Now, I didn't plan this to happen. I was going to show you guys this a little bit later, but it's happened here, so we'll talk about it. This is actually, we've done everything right, but that's actually not the answer. And let me explain why. If I were to take my answer and plug it into the original problem, forget what the original problem was. Maybe you guys can help me out. It was 1 over
X squared minus 2x plus 1 plus 1 x over wait, 1x equals 1 over x squared minus 2x plus 1.
Okay, so I wanna show you guys something here. If I were to plug in 1, and you guys should write this, by the way. Yeah, definitely. All right, I'll let you guys finish writing that, and then I'll explain it a little bit more. So let's review our steps really quick. So step 1 was to factor, right? Step 2 was multiply to cancel. And then the next thing that we did after that was we solved, right? So let's write that down. Solve. So you have those 3 steps. But I'm gonna add a third step here. And that is that you need to check your answers. It's not allowed to make the bottom equal 0. On a fraction, if you ever have a 0 in the denominator, that's undefined. It's possible that even though you do all your math right, you end up getting a 0 in the bottom, and that's what we call an extraneous solution. It's a false solution. So even though we did all our math right, we ended up with a bogus answer. And so actually, on the test, if you guys were to take a multiple choice test, you wouldn't choose the options that says x equals 1. You would pick the option that says no solution. Okay? So be aware of that. That can happen with rational expressions. I wasn't having you guys check for those yesterday just because I wanted you guys to get the basic idea of how to solve these. I didn't plan on it happening on this one either, but it did, so I figured we'll talk about it now. I was going to bring it up later today, but we'll talk about it now. So let's review. Step 1 is factor. Step 2 is multiply to cancel. Step 3, solve. And I guess now we'll check our answers to make sure we don't end up with bogus answers. All right, so here's a student practice. I'll let you guys mess with that for a little bit, and then we'll see how you do, and we'll move on. Oh, your voice. I'm sorry. Okay, I'll leave you alone. Armani, what's the next step?
Don't we check our answer?
We should check our answer. Now, I don't want to plug in 2/3, and I'm sure you guys don't want to plug in 2/3. So let me show you another way to check your answer without having to do that. If you guys just look at the factored form, like we had the following for the factored form, it was 1 over a plus 2 and 1 over a minus 2, right? It's easy if you look at the factored one. What would I have to plug in here to make this equal 0? -2. What would I have to plug in here to make this equal 0? So these are the only two answers that I'm not allowed to have. Okay? You would technically have to check it on all the other ones also, but they're the same, so there's no point in that. So the only thing I'm not allowed to get as an answer is 2 or -2. What was my answer? 2/3. So that's a good answer because it's not one of those ones. Does that make sense? So a equals 2/3 then. So the only thing a is not allowed to equal is 2 or -2. Since my answer didn't equal that, then we're good. That's a good answer. All right. We are gonna take it up a notch to one more level, and then we'll be done with the torture. Let's continue. And then spring break is upon us. All right. Go ahead and write down this problem here. We'll call this example 2 for today. I'm going to write that one down there. We'll call that example 2. Yeah. All right, guys. Now, why this one's harder? It's not obvious, but you'll see why it's a little more challenging as we work our way through the problem. So one thing that stands out to me as odd is we start off with a 1 there, but we've dealt with that before. If you have just a single thing without a denominator, just give it a denominator. So that'll be the first thing that we're going to do. I won't make that a step just because it's not that hard, and also it doesn't happen all the time. It's just if you happen to have something without a denominator. But the first step is still the same. We're still going to factor. Now I'm going to test your factoring skills here, and I'm going to ask Amaya, which of these denominators can be factored? No, not that guy. There's nothing I can do with that. There's no GCF, and it's not a difference of squares, and doesn't have enough terms for a box. So it's going to be this guy. That's the one that could be factored. What method is that? Well, it doesn't have 3 terms, so it's not a box method. It's not a difference of squares. It's close. This is a square, right? And this is a minus. The problem is 6r doesn't have a nice square root, so we're not going to go with that. This is a GCF problem. What can I take out of these 2 terms? We can take an r out, and if I did, what would be left inside? R minus what? Just r minus 6. So when you take the r out, they both lose 1 r, and you're left with that there. Okay? So this was a GCF one. We still haven't encountered anything harder yet. Okay, we're just doing another problem. Let me ask another person. Cal, what am I going to multiply every fraction by? Yep, but also one more thing. Another r, right? I don't really need to cancel out the 1. A 1 doesn't really mean anything. But I do need to cancel out the little r, and I also need to cancel out the r minus 6. So I'm going to put this on the top of every fraction, just like we have been. So that will be the following. We would have r minus 4, minus 6. I'm going to start by rewriting the problem first. And then I'm going to put those two binomials on, or not, there's not two binomials, put an r and an r minus 6 on the top of every fraction. All right, so let's start canceling some stuff out. So in the first fraction, the r minus 6 goes away. On the second fraction, the r minus 6 goes away. And since we're getting rid of denominators, I'm just going to go ahead and get rid of this one now as well. We don't really need it. You don't need to cancel a 1 out. It was just kind of there as a placeholder in the beginning anyway. So let's see what we have left. I've got r times r minus 4 is equal to r times r minus 6 plus r. Oh, I forgot. These r's cancel out too, so never mind. It's not r. These went away, so it leaves just 1 actually. That's not what I wanted to happen. Okay, so we'll go ahead and start solving. We're going to distribute. So now this is unfortunate because I wanted this one to work out a little differently. We're not going to see the hard part here. We'll see it on the next one. I hope. You guys see how there's an r squared here though? That's usually an indication that this is one of the ones that a little bit more work is required. But in this case, the r squared is going to go away. So on the one hand, that's a hooray moment because that makes the problem easier. On the other hand, that's sad for me because I wanted this to be something else. But, oh well. I'll put my r's together as well. And then we divide, and we get r equals a half. So that was a dud. I wanted it to do something else. But let's check our answer real quick. If I plug a half in here, you guys, will that make the bottom 0? No. If I plug it in here, will that make 0? No. So we have a good answer. We'll keep it. All right. Let's do a guided practice. We'll work through this one together. wonder if I want this one to work out right. Okay. See how there's two answers? That's the one I needed to have happen. It didn't happen. All right. So let's go ahead and do this. Go ahead and write this guy down. One of the hard ones up front, just by looking, you just kind of, as you work through, you'll see it. But a good hint is when you get to the solving step, if you see a square there, it's one of the hard ones. And then what really makes it hard is just the how you solve it. Is you have to use factoring. All right. What I'm going to do is I think I'm going to breeze through most of the first few steps because they're not different at all, but you guys should definitely write them down. So I'll talk my way through it. I'll go through it a little bit quickly, then I'll pause and wait for you guys to catch up writing. And when we get to the new part, I'll start talking again. Okay? But most of the beginning is not any different. So step one is to factor the denominators. That's what it would be if you factor the denominators. Those two would be GCF problems. I just took out a few. Step two would be to multiply to cancel. So I would multiply every numerator by those denominators. Which means I'm just basically going to put those on the top of each fraction. Still nothing new. These cancel out. These cancel out. These cancel out. And I'm left with P minus and that's where I'll wait for you guys. The new stuff will start kicking in there. We're going to distribute a -1. Okay. So, first of all, you guys see that there's a -1 here in the front. That's not, you got to watch out for that. Every once in a while, you'll have to distribute a negative, and that's just going to change all the signs for that second group that was in parentheses there. So let's do that. And here I would encourage you guys to write a note. You guys see how there's a square there? We had that in the last problem too, but the square is canceled, so I just kind of ignored it. But on this one, it's not going to cancel. So I'm gonna write a little note here, and I encourage you guys to write it too. When you have a quadratic term there, what you want to do is move everything over to one side so that it equals 0. The way that you solve a quadratic is not the same way you solve the little equations we've been doing before, where you just get the letter by itself. With quadratics, you have to get them to equal 0 first. All right, so let's do that. First of all, Notice most of the terms are on the left side. The only thing that I have on the right side is a 5. So let's move that over. We're going to subtract that on both sides. That way there's a 0 on this side. Also, guys, notice that we have two like terms here that we can combine. So I'm going to put those together. P and 2p is 3p. Next little note, I would have you guys write say now factor. Okay, so the way we're going to solve quadratics, we've learned two ways to solve quadratics here. One is by factoring, one is quadratic formula. If you like the quadratic formula, it will work. I don't prefer it, and I'm going to go with a factoring approach. Okay, but if you remember the quadratic formula, you want to do it, go for it. All right, so I do want to take something out of this. It's kind of like a GCF, but do you guys know what I want to take out of there? We don't like having a -1 in the front. It makes the box a little bit harder, so I'm going to take a -1 out. All right. Why don't you guys go ahead and do a box on this? See if you could box method that for me, though, and factor it up. I'll ask you what you got in just a second. Do a box method on that trinomial there. All right, and then what we do is we take each of those factors, set them equal to 0, and solve. So p minus 5 equals 0, p plus 2 equals 0, and we solve each one. So I get p equals 5, and p equals -2. Will either of those answers make the bottom equal 0 from the original problem? Nothing. I just take it out because it makes the box method a lot easier if it's not in the way. No, it won't affect the answer at all. Matter of fact, what you could do here is you could just divide this on both sides, and it goes away. And 0 divided by anything is still 0, so you can just ignore it. All right. So back to my question though, will these answers make either of the denominators 0? If I were to plug in 5 or 2, would that make 0 here? No. So we got good answers, and we'll keep both of them. All right. Sorry that was so long. Every once in a while they're like that. I'll throw one up there for you guys to mess around with, but I need to get a different one here, because that's another one where the squares cancel out, and I don't want that. So if you'd like to try that one there, that's one of the ones where you should get 2 answers. I'll just put the answers up there so you guys can check it. But if you want to give it a try, go for it. See how you do. You could. That's not how I taught it, but yes, you could. I would start with factoring first. But if you want to get creative and try to put those two fractions together versus one, that would be a possible route. But if you do that, you're kind of getting a little bit off from where I've shown you, so you might get a little lost. But if you want to try to be creative, you can. Yeah. Well, actually, if you do the box method for one, they're the same. So. Break your pencil. Making me nervous. So it was all fit. So just so you guys know our homework, I would like you to have it done by Sunday night like usual, even though it's spring break. So please do get your homework done by then. When we get back, we'll just have a review day because this was our last lesson for Unit 11. So when we get back on Monday, we'll have a review day, and then we'll be ready to move on. So.